Hello all, welcome to the Format String Vulnerabilities Primer for Hackers video series. In this series, we will look at how to go about understanding format string vulnerabilities and exploiting them. So let's begin. The first logical question, of course, is what are format strings? Now, very simply put, a format string is an ASCII string used to specify and control the representation of various variables. As an example, in the printf function, we specify the format string %d to tell printf that you should go ahead and convert I, the integer, in the form of a string. So the next question, of course, is exactly what is a format function. So a format function, example printf, uses this format string to convert C data types into a string representation. It is important to note here that the format string controls the various aspects of execution of the format function. We will look into this a bit later. But however, what it uses to control it is basically the number of variables which are specified in the format string and their representation in the result. So let's look at a couple of examples of format functions. Printf, fprintf, sprintf. I think most of you must be familiar with these. A couple of more uncommon ones are the vfprintf, snprintf, etc. Basically, these format functions belong to a special class of functions called variadic functions. And variadic functions accept a variable number of arguments. And these arguments are, of course, expected to be placed on the stack. The interesting part is that because they take in variable arguments, there needs to be a way through which the number of arguments can be conveyed to these functions. And this is where the input format string helps these variadic functions decide the number of arguments which need to be read off the stack. So as an example, just specifying %s in the format string would mean to printf that it needs to pick up a single argument from the stack. %s space %d would mean to printf that it needs to pick up two arguments. The first, a pointer to a string, and the second, an integer from the stack. So with this very basic background about format string and format functions, let's try and take up a very simple example to look at exactly what format string vulnerabilities are. I'm sorry about the constant honking of the cars. Currently, I'm in a crowded neighborhood in India, so you're going to be hearing a lot of those honkings going around. Apologize for that. Okay, so let's create a very simple program, format string simple.c. Okay, so this is an innocent looking program. All this does is takes argv1 and prints it back to the user, right? Let's compile this. Use the preferred stack boundary is equal to 2. In a later video, we'll discuss exactly why this is kind of important, at least to get started with understanding format strings. Okay, we've compiled it. Let's execute it now. Give it an input hi, and if you notice, it simply prints back that hi, right, as expected. printf takes an argv1, throws it back to the user, right? So now let's actually make a very simple change to this program. What we do is define a pointer to a string. Basically, this is a secret, right? This is what our string is. Let's name it secret. Okay. Now let's recompile the program. Let's run it. So we run it with hi. Of course, it just prints out hi. Now let's do something interesting. Instead of hi, let's actually give it %s. Now, if you notice, amazingly, it has printed out this is a secret, which is a secret string defined in the main function. And if you notice the code, there was absolutely no way by which this function could actually have printed the string secret in its normal course, right? So this is what format string vulnerabilities are all about. So very simply, whenever a programmer uses user input as part of the format string or the entire format string itself, as in this example, it is possible to go ahead and compromise the security aspects of the program. And this is where let's try out something, let's go one more step ahead and say, okay, let's define another string called secret2. This is secret2. This is secret1, right? And basically, let's actually go ahead, compile the program again. Now let's run it. So when we run it with format string given just as %s, we get this is a secret1. Now let's actually give 2 %s's. If you notice, now this is a secret1 and this is a secret2. Both have been printed out. So if you're already guessing this right, and if you kind of followed the buffer overflow videos, what is actually happening is that with each such %s being defined, what is happening is the printf function is just popping the next address from the stack. And basically, if you remember how the stack is organized, the pointer to these two strings, secret and secret2, are currently on the stack, right? If you haven't followed this part, we'll look at it in the next video, so don't worry. In this video, we just wanted to keep it very simple. Basically, if user input is substituted as part or whole of the format string, then it is possible to actually go ahead and print the program stack as well as the program memory, right? Now let's go back to our slides. So basically, what are format string vulnerabilities? Happens when user input is used as is in the format string, and this can lead to crashing of the program, viewing of the process memory, information leakage. This is exactly what we saw right now, and overwriting the memory with arbitrary data, right? We'll look into all of these 3 different type of things which can be achieved with format strings in later videos. So just to recapitulate, once again, when user input is substituted as part or whole of the format string, a malicious user can go ahead and either crash the program, view the process memory, or overwrite it with arbitrary data. Well, that's all for this first video. In the next video, we will look at exactly how the stack is organized and how variadic functions such as printf go ahead and use the stack to figure out how to print the variables which are actually passed to them using the format string. Well, that's all for this video. Would really appreciate if you can leave a comment behind in the comment section. And if you have any other recommendations, please post them. And we also recently started our forums. So if you have any follow-up questions, I would highly recommend that you join the forums, post it there, and I'll try to get back with an answer as soon as possible. That's all for this video. Thank you.